Alright, so today we are going to talk about number sets. So a number set is kind of like a basket. So a set of stuff is all different categories. And so today we're going to talk about number sets. And so imagine number sets like a basket. There's a really big basket. That basket is called rational numbers. So rational numbers are any number that can be written as in a fraction. Sorry, I'm having trouble writing. That can be written as a fraction. Such as a decimal. So like decimals can be written as a fraction if they are one of two things, if they are terminating or repeating. So like negative 2.5, that's terminating, so it can be written as a decimal, or a fraction, which is 1/4, right? Negative 1/4. There's also repeating decimals such as such as 1/3, which can be written as 0.33 repeating, right? So it repeats on forever and ever. So each of those decimals work because they can be written as fractions. Other things that can be written as fractions are whole numbers. You just put them over 1. So 8 over 1, negative 8 over negative 2, because really what is negative 8 over negative 2? Well, it is positive 4. So that is actually a whole number, and since it can be written as a fraction, then it is a rational number. The next set that we're going to talk about are the integer sets. So an integer is the next basket that goes in our big basket. So rational numbers are our big basket, integers is our next basket that goes in there. So we're going to cut out numbers. So the numbers we're going to cut out are actually numbers that have fractional or decimal parts. So the only thing that integers are they're negative, 0, and positive numbers. So like negative 5, negative 4, negative 3, negative 2, 0, 2, 5, 7. All those are integer numbers because they don't have any fractional parts, but they are still a rational number. The next, I wrote on it. The next basket is a whole numbers. So again, we're going to get it smaller. So we're actually going to kick out, let me write that better. We're going to kick out negative numbers. So whole numbers are just 0 and all your positive numbers. So a way you can think about whole numbers is if you divide by them, then you always get a positive number. Or you get another whole number. So like 4, not a whole number, but another positive number. So like dividing by 0 is good, dividing by 1 is good, things like that. Sometimes as teachers get off talking about stuff, and it's not really what I meant. I didn't mean that when you divide by a whole number you always get a whole number or you always get a positive number. I just mean that it's always 0 and all your positive numbers. So we have 0, 1, 2, 3, 4, and so on up to like 3 million, billion, trillion, gazillion, all those numbers to infinity, all the positive numbers. And then counting numbers, really, you just get rid of 0. So it's our next basket, and so we get rid of 0, so it's just positive numbers. It's what your parents teach you to count with. They teach you to count at 1, and then you go up from there. So, I know my paper's a little sideways, so if you want to turn your screen sideways or not, you can. So the way it works in this Venn diagram is you want to think about it like retro iguanas waving numbers. So when you think about it like that, and it's just a little acronym to help you remember, you can realize it's rational numbers, integer numbers, whole numbers, and natural numbers. So I'm going to give y'all a couple examples, and when you bring this back to class, I want you to add in a few more. So my examples for rational numbers are going to be -1/2 and 0.4 repeating. My integers, I'm going to have a negative number, -2, -5. Whole number, I'm going to leave as 0. And natural, I'm just going to have 1, 2, and 3. So I want y'all to get creative with some numbers and see what y'all can come up with.